So I'm going to speak about time series analytics today, and that's going to resolve around a time series database called KDB, which is owned by KX Systems. So first off, if you can't hear me, just say. I'll try and speak as loudly and as clearly as I can. KX Systems is a subsidiary of First Derivatives. It was founded in 1993, that's KX, and it's about 2,000 employees worldwide, so it's a global presence. We are all set up from Newry, and obviously some of us here working in Glasgow. So these are just some of the partners now that KX Systems would work with. As you can see, a lot of these come from the financial sector. It's not something that we would say that this database is specific to the financial sector, but it just happens to be that it's grown out of that sector as they were the businesses that really needed time series analytics. So again, we're just moving into some of these other verticals now. As data volumes start to grow, we're able to move away from the financial sector. So you can see here automotive and retail, space and telco there as well, and the manufacturing industries. So just a bit of background on where KDB Plus as a platform came from. There was a guy called Kenneth Iverson wrote a language called APL. And the idea behind APL was that everything was thought of as a list or a vector. So back when this thing was written, he actually won the Turing Award for this paper. And it was written in using a lot of scientific notation, so it wanted to be as close for scientists and mathematicians. So moving on from that, there was a guy who worked with Kenneth Iverson called Arthur Whitney, and he wrote a language called A, which became A+. And he also wrote a language called J, and then moved on to K, which is the predecessor to a language called Q, which we'll jump into a lot more. Just very original names, but here we are. So KDB Plus then, it's a unified conglomerate database and programming system. And what that means is it's basically a database with a programming language built on top of it that allows us to run analytics on the data. So maybe that's a wee bit vague. What we're saying is we're going to run the analytics on the data itself as opposed to having your server and your application server as well. So we're not pushing data back and forward. It's built around a Lambda architecture, which is an architecture that's basically used for streaming data, so massive amounts of data coming in, where we're going to have our real-time in-memory data, so very fast access data, and then we're also going to have some data saved down to disk. So where we spoke about the in-database analytics, we're not going to query something, have data come sent across to another server and then run the analytics. We have support for joins, so we're going to have all your basic SQL joins, and then some more on top of that as well. So it can sort of be thought of as like a superset of what SQL. And it's very small, so it's only 500 kilobytes for the entire thing. So we'll speak a wee bit more about that as the slides go on. So this is your typical KDB Plus architecture. It's not an end-all solution, but it's just a reference to give us a wee chance to explain what's going on. So we're going to have the data coming in to an events engine. We would sort of refer to this as a ticker plant. And the first thing that a ticker plant is going to do is log all this to an on-disk log file. You would have this saved on some sort of fast access memory, so that for any reason, if one of your subscribers here, whether it's be the streaming queries or the real-time database goes down, you're able to get full recovery and replication from this log file. So once we have our data coming in through a ticker plant, the job of the ticker plant is just to push data downstream. The next subscriber to that is what we're going to call a real-time database. And its job is to take all the data that the ticker plant is pushing along. So this is going to be very memory intensive, but not very CPU intensive. So the job is going to take the data from the ticker plant and push it all into in-memory tables. And other subscribers, so we can have multiples of all of these, and it can be built out as you need. But for example here, a streaming query engine would be, let's say we're going to perform a calculation across this data. So if you want to aggregate volume weighted average or something along those lines, where be a lot more CPU intensive and a lot less memory intensive, as you need it. If it's not financial data, it could be Fitbit data or smart meter data from homes, where you could be, let's say, calculating the kilowatt per hour usage across postcodes or anything like that. So what we have in orange here is any data that's going to be held in memory. And then at the bottom here, we're going to have anything that's going to be held on disk. So at the end of the day, or the end of the session, whenever it's going to be, the job of the events engine at the ticker plant is going to send a message to all of its subscribers. So in this case, your streaming queries and your real-time database, and it's going to say, let's flush our in-memory tables and let's put them all down to disk. So we're going to be able to build up an historical database. So just a quick overview of that. And here what we're looking at is, we're just showing the sort of data models that we're going to use. So at the top we have our in-memory tables, so our RDBs and our streaming queries, and we're just showing these are all going to be in vector or column arrays. The same, it's on disk, except it's all going to be in files. So it's very much built around this idea of vectors and columns. Speak a wee bit more about this, but the basic data types we have, we're going to have some Boolean types, there's some character types there, some integer types. We have a symbol here, which is very important in KDB, and we have this GUID type, it's just a global, very unique, so we're able to get very fast searches from it. We also have tables and dictionaries, key tables, functions. So because it is a time series database, obviously the time series data types are very important. So we'll have date, time, minute, second, month, date, time as you'd expect, and we'll have these very granular time span and timestamp. They're built down in nanoseconds. So one of the cool things you can do with KDB is that you're able to save your data down in its most granular form and build it up quite well from that. So if you were to save something down in nanoseconds, you're able to analyze that in minutes, and it helps to be able to bucket up and do some nice analysis based off that. So Q as a programming language is what we build on top of the database itself. So the database is a relational columnar database. The Q language is what we need, a nice expressive language on top of that. So it is a function language. It comes with about 220 functions out of the box. We have your standard SQL functions, your first, last, min, max type of things you would need for a time series database. And obviously we keep coming back to this idea of columnar and vector analytics. So what we try to do is get rid of for loops, while loops, and we do that by having functions performed against vectors. So it's also a query language, so you have all your SQL functions, and then you're also able to build up your own functions and include them in your SQL queries. So it's not, we call this our SQL language, or QSQL language, sorry, which is built on top. And KDB Plus itself is an interpreted language, so we aren't building something, or we aren't writing a query, having it compiled, coming back and running it. Rather, we're having very small, concise code, which we get from having these functions running across vectors, that we're able to have a very nice response from the console, and be able to fire queries in and get your results back very quickly. So again, your functions that would apply more for the time series stuff are your XBAR. So here we're going back to our time series data types. We would use XBAR for bucketing. So it's you're going to take quotes or trades in every couple of seconds. We can then bucket them up over the course of days and minutes as needed. And we have some bitemporal joins. So here what we have is your as of join and your window join. And kind of what these are is that we say we want to make a trade, and we're going to make this trade compare to a quote table. So we'll find what the quote was as of this time. So we'll kind of do a binary search going back up to find what the quote price was at any given time. And we briefly touched on the fact that temporal arithmetic is very easy because it is a time series database. So we're able to do plus and minus and times dates. Quite simply, date minus 7 will give us a day from a week ago. So we're trying to get across the point of it being very easy to use, very fast, very simple. And the data itself, so we have some attributes that would apply to the data. We would try and use these very sparingly, but you can get very good performance increases if you use them. So some of these are better served on disk, some of them are better served in memory. Typically what we would expect here is we would have a sorted attribute which would be applied to lists or vectors, tables or dictionaries, and we would expect that if a table is sorted, then we expect that it's sorted in ascending order, and KDB is able to use a binary search then instead of a linear search, for example, which increases your performance. So going through that, you have parted as well, which allows the KDB Plus to find the unique values very quickly, and also makes it aware of where the segments start and finish for that. So we have unique and grouped as well. Grouped is sort of a lot closer to what you would traditionally find on other database technologies, so sort of like your indexing. So KDB Plus also provides a way of parallelism. So it does this in a few ways. One is your vertical scaling. And what we mean by this is building up the amount of memory and cores on one particular machine. So KDB, we're not going to have an API sitting on top of the KDB Plus database, rather that this is all abstracted away from the end user. And if you have a query or a function that's able to be parallelized, then KDB is going to do that for you under the covers. So it'll split up a query across multiple cores as needed. To do that, you're just starting your Q console with a number of slave threads, and then all of that is taken care of for you. So in the most recent version of KDB, there's no serialization between those threads now. So that's a big performance increase as each thread's running in the same memory space. And as I said, it's distributing those queries across CPU cores. The horizontal scaling then is distributing those queries or functions across, let's say for example, multiple processes which don't have to be in the same machine. So what we can do is quite nicely and quite easily build up one function, and this is more so for historical data, maybe going back many years, where we can split the query up and have it running processes across multiple machines, taking advantage of that. So it exploits the Intel vector instruction sets, so your SSE instructions, which again keeps coming back to this logic of everything should be vectors, lists, columns. The native MapReduce is just the semantics are built into the KDB language, again in that 500 kilobyte binary, which we'll cover a wee bit just of how much is in that 500 kilobyte binary, but it's able to sit in L1 or L2 cache, which allows you a lot more space for the data. So again, it's coming back to performance. With the small binary, there's able to cache a lot more data once you page fault the data in, and you can take advantage of the OS cache. So a few more things that KDB provides. So because it is a 500 kilobyte binary, it's very small, very fast, it's bare bones. And the only library dependencies that it actually uses that aren't OS system calls come from these compression algorithms. So in your 500 kilobyte binary, again, we have a WebSocket compression. It supports, there's a HTTP server in there, a WebSocket server, and it's in-flight compression between hosts. So if we are sending information back and forward between machine A and machine B, we'll use this KDB Plus algorithm, which we can also use on disk, which is built for speed. So your gzip and your Google Snappy is going to compress a lot better, but then your decompression is also going to be a lot slower. So your encryption then, there is it's supported for SLS and TLS for your in-flight data, but any on-disk encryption is left to the OS. So because everything's stored in a file and folder format, we're able to leave that to the operating system. Then we also say that you don't have to use Q to be able to take advantage of Q. So there is a lot of interfaces out there, and there's more being added all the time. Typically here, just a few examples, and there is a lot more on the code.kx page. If we take, these typically work in one of two ways. Either you're going to have a TCP IP connection, we're going to push data back and forward, or we're going to have, let's take for example Python here. The Python interpreter can run in the same memory space as the Q interpreter. So there's no need to push memory or push data back and forward between processes. You can use the Python interpreter to query or manipulate KDB data. So there's a lot more information on that on code.kx. And just to help things, the Windows 10 update's going. Smooth. Yeah, so in case I haven't emphasized this enough, KDB is a very, very fast language. There's just a few bits of information here trying to demonstrate that. So I briefly touched on the fact that it fits entirely on the L1 and L2 cache. So one of the ways that we see the benefits of this is that if we have all of our data from today's data would typically sit in memory, so we're able to get very, very fast response times from that. But if we are querying data from a couple of days ago, we're able to load quite a lot of that into the cache, And then the second time round, if we need to query it, we're getting nearly in-memory performance because we're able to get so much into a cache. Just a few snippets of information then from that. And then we're also involved in some benchmarks. So the stack, there's the Security Technologies Analysis Council, and they do independent benchmarks. KDB, I think, has been chosen as a database solution of choice for over 95% of that. And there is another benchmark done by a blogger for the New York taxi rides as well, where KDB has come out very well. So just a few additional resources then. We have a 32-bit version of KDB available on kx.com. As you can see, it's built for a number of platforms down here in the left-hand corner, so Windows, Linux, Mac. Again, it fits in Raspberry Pi because it's so small. And it is a pure software solution, so we're able to demonstrate that pretty easily. Here then we have code.kx, which, so kx.com is for your more the commercial side of things. Code.kx would be for developers. You can learn the language here. There's white papers here as well, so for things like your attributes, which we would apply to that data, there's a lot more information there. There's one more thing here as well. I don't see it being the code.kx now, where you're able to go into a lot more detail for the interfaces, so your Python or C++. We also have some Google groups, so the community is very responsive if you're throwing questions in and out. And then it's also monitored by KX developers. So if you are asking a question and it's not being answered by the community, then somebody from KX will jump in and do that. And there's a couple of GitHub repositories. So KX go and try and group together a lot of the APIs that are getting built out there. And then the second sort of GitHub repository would be KX approved APIs. So this is where you're going to find your C++, your C interfaces, your Python, your OR. And obviously Meetups, which I'm assuming you have seen somewhat since we're all here tonight. And a couple of books as well. So on the left-hand side, we have Q for Mortals, which would be like a nuts and bolts version if you wanted to learn the language. And on the right-hand side, we have a Q-Tips version, Q-Tips book, which is written more from an implementation side of things. So they go together very nicely. And well, thank you very much for your time. Hopefully that's some sort of an overview of KDB as a language.